So we've already discussed the importance of making careful measurements in science and recording not only what value you get, but how sure you are about that value. And important discoveries have often been made by looking very carefully at measurements and noticing small discrepancies from what we expected. And those small discrepancies eventually led on to big discoveries. But sometimes just making a good old guess at what something should be is an incredibly powerful tool. And the reason for that is that when we're trying to figure things out, the most important question we start with before we start doing all our calculation is, well, what's important? What things should I consider for this calculation to figure this thing out? And figuring out what's important often involves thinking about possibilities and then estimating to see whether they're relevant or not. Sometimes they'll be really important, but often they won't be. And that's where estimation will be a very powerful tool in getting you started on any kind of real-world problem. Now, there's no sort of formula to learn or rules to learn about how to estimate things. Really, it's just something you learn to do by practice. So I'm going to do a few examples to give you a sort of an idea, and then you can have a go at some yourself. So let's start off by trying to figure out what fraction of an apple's price comes from the truck that transports it to the supermarket. Alright, so the first thing to realize is that we're going to have to make some guesses. We can't just answer this question because I have no idea how much of an apple's price comes from its transport by truck. So I have some idea how much an apple costs. There's my apple, and it costs maybe 50 cents. And now to have some idea of what it costs to transport a truck from, say, the farmers markets in Sydney down to Canberra. So I've got a truck full of apples traveling to Canberra. Now I'm going to guess that it costs maybe $500 for the human to drive down and back. That's basically a day's work. Maybe that's a massive overestimate, I don't know. And I'm going to guess that the petrol cost is going to be about another $100 or so. So that's 2 tanks of petrol for a car. Maybe that's a bit low, but it'll be the right ballpark. It won't be $1,000. And the $500 is probably a bit high, because I understand that truck drivers lead fairly frugal lives. Okay, so the real question now, in order to try and figure out how much of this 50 cents here is being affected by the cost of transport, is to figure out how many apples are going to be in that truck. And this is where our guesstimates are pretty bad. If you asked me to guess how many apples would fit in a truck, I'm not sure I could get it right to a factor of 10. So I'm going to do a little bit of thinking now, and this is where we use all our practice in scaling. So the normal size of an apple, it's roughly a sphere, and I guess it's, 10 centimeters? So I need to figure out how many of those are going to fit in my truck. Okay, so how big's a truck? A truck is meters big, I guess. This would be, I used for my chocolate example, I used 4 meters. Let's use that. 4 meters, and it might be maybe 2 meters high, about a person's height. And maybe 2 meters wide as well. And so now I just do a volume calculation. So the volume of my truck is going to be 4 meters by 2 meters. How wide shall we make it? Approximately 2 meters. Now if I get these numbers wrong, then I'm going to get the wrong answer. But I'm not going to be too worried about that, because what I'm just trying to see is whether it's significant or not. If I get a really tiny fraction, then it doesn't matter if I get it wrong by a factor of 2. It's still going to be tiny. On the other hand, if it's comparable, if it's maybe half of the cost of an apple, then I'm going to go, oh, this is really important. We should be far more careful about these numbers. Okay, so that's my volume of a truck. So that's going to be 4 times 2 times 2 is 16 cubic meters. My volume of my apple is 1,000 cubic centimeters. Now, what's a cubic centimeter in cubic meters? I could take this previous thing and I could multiply by 1 meter divided by 100 centimeters. That would cancel one of those centimeters and leave me with a meter, and I could do that again and again, and I could end up with the completely equivalent answer of 1,000th of a cubic meter, which is 10 times 10 times 10 divided by 100 divided by 100 divided by 100. So once again, we've made the step of making a very simple version of the formula for the volume of an apple. I just said it's about 10 centimeters, and so I assumed it was a 10 centimeter cube. And of course, you might decide that an apple is more like a 10 centimeter sphere, but again, that's only going to change the numbers by a little bit. And we are only trying to see whether the price from the transport of an apple is significant or not. Okay, so what we can see is we've got 16 cubic meters of truck and 1,000th of a cubic meter for an apple. So the number of apples that we can transport is about 16,000. And the price is about $600. And so the price per unit apple comes out to about 4 cents per apple if we round up. So what that tells us is in fact that the truck transport from the market to the supermarket is a fairly small fraction of an apple's price. And if I was to adjust these numbers, I might find it more accurately, but I don't have to worry too much. It's not like it's all coming from that truck.